which we already are. All right. 11.1, expressing roots. We are doing radicals. Now, this isn't bad. The radicals tend to freak some kids out. Those kids that may not be real strong in math, they may it may stress them out. Okay? Or, and I've seen this happen, some kids actually do really, really well with radicals. It's like they just get it. So don't freak out. We're going to go slow and steady. Take good notes. I've got a lot of notes today. So let's kind of review a little bit. 3 squared is very good. Now, just to remind you, that would be 3 times 3, right? That is not 3 times 2. See, I'm having to remind you all this. That is not 3 times 2. 3 times 2 would be 6, and that's not correct. 3 squared is 3 times 3. What about this? This is y'all's favorite. And some of y'all are like, oh my gosh, it's on the outside of the parentheses, so is it negative 3 times negative 3, or is it 3 times 3 with a negative on the outside? New, what is it? Very good, New. See what happens? Y'all, she is out of sorts. She kicked the wall earlier, and she can't do negative 3 squared.
I was actually happy.
All right, this is like Twilight Zone. Oh, no.
But it was out of joy?
Yes.
Oh, okay.
It's
out of joy.
I thought she was mad.
Yeah.
All right, I thought she was mad, and I'm like, oh my goodness. All right, that's the same as saying negative 3 times negative 3. Right, New? All right. Okay, so our brains are working. We know what we're doing here. Now, yes, they are. Square root of 9. Anyone want to tell me? Chat.
3.
Very good. Or, here we go, taking it up a notch. It could be negative 3.
If it's negative 9.
How do you know? Negative 3 times negative 3.
No, how do you know?
How do you know which it is? Okay. You don't. The answer is going to be positive, negative 3. Because now, boys and girls, radical signs mean a whole new thing. Because like last year, up until this year, y'all have all just thought it was that. Oh, that's easy. But now you know it could also be a negative 3. Because negative 3 times negative 3 gives a positive 9. Do y'all see that?
We probably asked this question when we went over radicals the first time.
What if? Oh, yeah.
You probably did.
What if? Okay, I know y'all did. All right. There's my star. Franz. You need to be writing all of this down, trust me. That is not a weird division sign. It is called a radical sign. I know you know this. You're writing it down because I said so, bless you. You need to know it's a radical sign. You need to know some vocabulary. That 9 that's under there, anyone know what it's called?
The constant.
Y'all are cracking me. Don't look in your book, you cheater.
Oh, that's a good idea.
Oh my goodness. It is the radicand.
Oh, yeah, we learned that last year.
Yes, you did. Okay, do y'all see why I don't like these standardized tests that are coming in April? Because you're like, oh yeah, we learned that last year. But did you remember? No. Okay, that is the radicand. You need to know that. I don't like that noise. All right. that would be your, what's the square root of 9? 3. What's the square root of 16? 4.
You just said it could be.
Shh. Just write it down. I said positive. See the word positive? Mm-hmm. Now, if I say negative, that's if I want a positive there. What if I have this?
-4.
That's going to give you your -4.
Is that like the you know,
Distribute the,
distributed
like,
property? Yeah.
like
And
where
make
it's
it
always on the
opposite.
outside and then you,
Yeah.
Sure.
but it goes to the answer, not the thing on the inside.
Correct. It goes to the answer. That would be -3.
Yeah, yeah.
Right, you can't
Yeah, I
have
don't
negative
know.
on the inside because it wouldn't be a square. It wouldn't be a perfect square.
Now I'm going to have to throw something new at you.
No.
Yes. See that negative sign? You got to make, first of all, make sure that when you see the negative sign on the outside, then it's going to give you a negative answer. Real quickly, what if I'm going to put it right here? What if I have this?
It's not a perfect square.
It's not real number. You can just say not real. If the negative is on the inside, it's not a real number. It's not real. It's false. It's
just
bad.
A dream.
Yeah, it's just a dream. The negative's on the outside, then you get, your negative answer. Oh no, new.
And then one question.
What?
What is this, the negative on the outside and on the inside?
Then I believe it's still not real. Okay. Because there's nothing that we could do. There's nothing we can do to get a -16. -4 times -4 is a +16. You see what I'm saying? So there's no way to get the negative on the inside. All right.
-4 times positive.
No, okay. Now, this negative sign tells, you better write this down, you if they want a negative root or not. We're going to talk about that later. Okay. Now, that's basic stuff. Now, we start the strange stuff. Y'all ready?
Or not.
Okay. Let's see. I'm going to start with this right here. A star. There's my radical sign. Is there anything in that little check mark?
Not yet.
Do you see anything in that check mark?
Yeah, put the next one in there, aren't you?
Wait, do you see anything in that check mark?
No. A lot. Well, no.
Nothing means 2. It's understood.
Oh, I get it.
Oh, let me show you.
So an X is not understood?
So the 2 means it's like the square root, and the 3 means like it's cubed or something.
Oh, yes. That's right. Square root. Perfect. For example, if I were to do the square root of 9, that is 3. That means 3 times 3, correct? Is there anything here? We pretend there's a 2. So that is the same as this. It really means 3 times 3. Because look, if there's a 2 and there's 1, 2 numbers, when multiplied, give you the radicand. So the root tells you how many basically roots or numbers that when multiplied is going to give you the radicand. If there's a 2 here, then we got to find 2 numbers. Now watch this. Ariel, you awake? Make sure you have this down. Does everyone have this down? All right, here we go. Cube root. Here's where it starts making sense. Cube root looks like this. Has a 3 in there. Not necessarily an exponent, but yes, a little bitty number. A cube root looks like that. So remember, if there's nothing in there, we assume it's a 2. Otherwise, they're going to tell you there could be a 4 in there, there could be a 5, but mainly we're dealing with 2s and 3s. So an example would be what's 2 cubed? Boys and girls?
8.
So that would be written, for example, if I had this. That's a 3. So what number times itself 3 times? That's the root. Is going to give me 8. 2 times 2 times 2 gives me 8. So the answer is 2. See, the root is 3, so there's 1, 2, 3 numbers. Yes?
So, if it's like this, does that mean you can have a negative with these?
We're about to talk about that. Okay, so anytime they have the little number there, they're saying what number times itself that many times is going to get you the radicand. Ariel, if I see your eyes closed, you're going to the office. So if you need to stand up, take the mask off, breathe, take your jacket off, whatever, you need to do it, okay? All right. You will not sleep in my class. All right. Nth root. Nth root. That means it can be any number.
So any number above 2 and 3.
On the calculator, yeah, exactly. On your graphing calculator, it looks like this. There's an X there. So if you have a graphing calculator, you're not getting it out right now. If you have a graphing calculator, the symbol or the button's going to look like that. Okay? So the nth root, and like Franz said, it's going to be any number. It can be 3 or higher. Okay? So for example, let's say I have, oh my gosh, not 88, 81. 9 times 9 is 81, but this root is 4. So we're looking for a number that when multiplied by itself 4 times gives us 81. Shh, did I call your name? I didn't call your name. No, I never said Franz. So we're looking for a number that when multiplied by itself 4 times, do y'all see that? gives us 81. And the answer is what, Franz?
3.
That is correct. It is 3. And you can check yourself by applying the root to the number. And that would be 3 times 3 times 3 times 3, and that gives you 81. Keith, you write it down? Good job. All right, any questions? All right, more information. So do you understand how those roots work? All right, so remember, whatever's in the little check thing right here tells you what they're looking for. It could be 3 numbers when multiplied together, give you the radicand, 4, 5, whatever. It gets hard as they get bigger, but you know. Keith, are you with us? You seem really happy back there. You okay? Okay, making sure. All right, let's do an even root. All right, you need to write this down. It's important. Even root. And what they're referring to is if the root is even. The even root of a negative, this is what you're talking about, number is not a real number. All right, so if there's a negative and the root is even, it is not a real number. Like when I was showing you over here, what is the root? What's in the check? 2, because there's nothing there, so there's a 2. Is 2 even or odd?
Even.
It's even. So then that is not a real number. That's what this means. An even root. Any number here, any root that's even of a negative number is not a real number. For example, let's go ahead and put the 2 in there. Write this down. Get away. Okay, so my root is even. I have a negative radicand. That is not a real number. And let me show you why. This would be your answer. Not real or not a real number. Because the only way we could do -2 times -2, that gives me a positive. That's not going to give me a negative radicand. And of course, 2 times 2 gives me a positive. And it doesn't work. So there's no number that times itself by an even number is going to give you a negative radicand. Let's check another one. Let's say I have this. The root is 4 and my radicand is -9. First of all, there's no number times itself 4 times is going to give you 9 anyway, right? Mm-hmm. Okay, but even then, because this is even and this is negative, then it is not
No real number.
a real number.
We just put not real.
You're going to write it all out because I said so. Because I'm mean. What?
So it only matters about the number that's between the check
Mm-hmm.
and
So Other number doesn't matter.
The radicand? That's correct. So all you're looking at is that root and if the radicand is negative or not. If it's even and this is negative, it's not a real number.
So what happens if you have a negative
Oh, we're not going to have negatives.
number?
Oh, no. Let's not go there. But we could have an odd root. So let's talk about that. Y'all have all this down? Sophia, you got it? Valeria? Ariel, you awake? All right, good. I will make you dance if you fall asleep. I will embarrass you. Oh, boy, will I embarrass you. Ask Sophia what I did to her sister yesterday. That's funny. She fell asleep in her class. The whole class left and hid. I woke her up and made her think that it was the end of the day. It was hilarious. All right. She started looking at the clock and looking around. All their stuff was still on the desk. It still didn't register quite right away that what was happening. She had marks all over her face and her hands. She was out, y'all. All right. So, odd root of a negative. And then I get to take pictures of you and make memes and post it all over social media. All right. Odd root of a negative. And I would not do that, just so you know. I do of my cat, but not of my students. Odd root of a negative number is a negative real number. So it works. And I'll show you why. So odd root of a negative number is a negative real number. I'll wait for y'all to catch up. For example, and yes, you will be having fractions. The cubed root of negative 27 over 120. Oh, man. All right. The cubed root of negative 27 over 125. First of all, this is odd. This is negative. It does work, so it is a real number, but that's not your answer. I'm just writing that down for your notes. It is, bless you, a real number. So keep in mind, if the root is odd, but the radicand is negative, it's okay. Now, just like this one, when we had the fourth root of negative 9, there is no number that times itself will give you a positive or a negative 9, 4 times. So you have to decide what times itself 3 times will give you this. So what we're looking at is what times itself, and it's going to be a fraction, 3 times gives us negative 27 over 125. So what number on top multiplied 3 by itself 3 times gives us 27, and on the bottom, Franz, you want to? Okay, so watch this. Negative 3. Negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is negative 27. What number goes on the bottom? Chap?
5.
Very good. So negative 3/5 times negative 3/5 times negative 3/5 gives us negative 27 over 125. So the actual answer is negative 3 over 5. So if you were to be given this on a quiz, the answer is negative 3 over 5. See, this is where it gets tedious. You've got to sit there and figure out what number times itself, however many the root is, will give you, 27, 125. Do y'all see how that works with the negatives now? Y'all see that? Okay. Any questions so far? Okay, sure. I'm so happy you are. Stay awake, Ariel. If you need to stand up, stand up. Take your jacket off, cool off, something like that. When you're toasty warm, you will be out.
That's true.
I mean, seriously, stand up if you need to. I don't care. DJ. He
He
stood.
sleeps in class. They don't care anymore.
No. He stood in the back of my classroom all during Algebra 1. Stood right about where you're at. Used one of the cabinets as his desk. Kept him awake and focused.
Nah, he just sleeps now. They let him. They don't care.
Oh, yes, they do. I hear about it on a regular basis. Trust me, they care. All right. Look at that root. So what we have is odd and a negative. Is this a real number?
Yeah.
Why is it?
Actually, no.
Why isn't it?
There's no number multiplied by 5 they can get.
Oh, no. First, it's an odd root and a negative radicand. So can it work? Could it work?
Yeah.
Yes. This would be considered a real number. So y'all write that down so you remember. Now we got to figure out what number times itself 5 times. Not a fraction. I'm just writing the spaces down. What number? Wait, raise your hand. High in the air so I can see it, Keith. Not like this. There you go. Thank you. That's what I want to see. What number? Very good, Keith. -2 times -2 times -2 times -2. All that. Negative times a negative is positive. Positive times a negative, negative. Negative times a negative, positive. Positive times a negative, negative. So that's what I'm talking about. It can be stressful. Because you got to find one number that when multiplied by itself, however many times the root is going to give you that radicand. So the answer is -2. Awesome. Yep.
So any odds will equal negative and any
What
even will
if
equal
you
positive?
have
For
an odd
the
Correct.
like
lowest
that,
number.
but you can't.
Wait. I had 2 people talking. Start over, Miranda. You asked, and someone else interrupted.
What if you have like an odd negative like that, but you couldn't get anything multiplied by itself? Like
Then
five?
it wouldn't work. Just like this 9, right?
See,
What?
but not a real
Yeah, it would work. They're not. I don't think they're going to do that to you. It's like the last chapter we did with all the primes and stuff like that. They're not going to do that. All right, moving right along. Any questions about this? None? All right, I'm turning my page over because you're going to now learn something completely different. Exponential and radical forms. Exponential and radical forms. Okay. So much to remember. All right, y'all ready? This is something else you gotta remember from and guys, keep in mind, this is 11.1. You know how the first section is always the easiest? Look at all this that they're giving you in the very first section. So,
Thanks for the confidence boost.
well, prepare yourself. All right, so for example, exponential form has the word exponential in it, right? So you know we're going to be dealing with exponents. Don't freak out. All right, those of you in the back, that's a big old X. with an exponent of a fraction of a over b. Don't freak out.
Why?
This is your exponential form. That right there.
And it's probably gonna go check mark line over.
So if I say put something in exponential form, this is what it's going to look like. Do y'all see that? It's a base with an exponent that looks like a fraction, okay, as your exponent, right? Makes sense, exponential form. All right, radical form. Watch this and it's going to start making sense. There you go. There's your radical form. So, B represents what, boys and girls?
The denominator.
Okay, but what is this?
Oh,
Exponent.
Okay, we call it the root, sort of thing. It's going to be, you're right, the denominator. So whatever number's here is going to be a denominator. So for example, this 5, that would have been a denominator. This 3, denominator. See where I'm going with this? Oh, y'all are not with it today. Y'all are just scared or something. Or you can write it as this.
Same thing.
It's the same thing. It's just written with parentheses. So the A is going to be your little exponent with the base, and it's going to be your numerator. So the only thing you got to memorize, really, and I'm going to show you examples. Oh, chap, it's not scary. I promise. It's not as scary as the last, couple seconds of Baylor's game last night. Okay. Anyway, all you need to remember.
So that's all that matters.
What?
I said Houston won, that's all that matters.
Exactly. That's all
Baylor
that
will cream
matters.
them.
Whatever. We'll see.
Yeah, you will see.
Cougars rule. Okay, anyway, you need to remember that the number in the check mark is going to be your denominator, and whatever the exponent is going to be your numerator. For example, let's say the exponential form is 8 2/3. Where does my big 8 go?
You need
It has a radicand.
It's the radicand. Where does the 2 go?
no. It's in with the radicand. It's the
Sophia, what is it? What's the 2? Okay, it's the exponent for the 8. And then the 3, which is a denominator, it goes in the check mark.
How would you solve?
You don't need to worry about that right now. Or you could write it in parentheses with the 3 in the check mark, 8, and then 2 on the outside. It will be the same thing.
So the 2 would go to the answer?
The 2 wouldn't go to the answer.
Like you wouldn't solve the radical first, like 2?
This,
Yeah, you wouldn't solve, like with the parentheses.
that would be 64. It'd be the same.
So the,
This is applied only to that.
okay, so you have to apply that first before solving, like saying 2.
This would be the same. This
Okay,
would
so
be the
only-
same as.
Okay.
Okay, let's do another one. Let's say this time I have this. Write it down, write it down. What would my exponential form look like, Miranda?
5, 2,
Yep. Or we could write it like this. Make sure you write all this down.
Wait, so these are like answers?
This is how you write both of them. This is how you write it. Does it make a little more sense? You just have to remember that the exponent is always the numerator, the number in the check is always the denominator.
Why?
That's the rule.
it's math, don't question it.
What if I give you this, Morgan? That's a 3 right there. What would the exponential form look like? This is your radical form.
I'm still writing.
That's fine.
X with 3/5 is the exponent.
Yep. That's a 5. Y'all see that? You're going to have to be able to go back and forth, back and forth. Any questions about that? Let y'all copy it down. I got more. What if I have this? No, not yet. Y'all have never done this before. Okay. This is, to solve this, you have to follow a rule. You have to follow the rule of when you are adding fractions. It's what you're basically doing. What's the rule when we add fractions? You have to get a common denominator. All right, so what are we doing here? Do we have a common denominator? So how do we get a common, what would be the common denominator here?
4.
Ariel, what's the new numerator here?
2.
There you go. Now that we have a common denominator, we can put it in radical form. What goes in the check, boys and girls?
4.
Bingo. So in here, I'll have 3. What goes with that, Valeria? What would be its exponent?
2.
There you go. And then x to the what, Miranda? There you go. So to be able to combine these, bless you, you have to have a common denominator. It's like adding fractions. You have to have a common denominator. So then the denominator becomes your root, goes in your little check. And then you put your bases in there and apply the exponent. What is 3 squared? Anyone?
9.
There's your answer. So sit back and look at that, see what we did there.
I understand.
Yes,
So is that simplifying it? Since like
that you're done.
so like you can't go any further.
You can't go any further. You can't go any further because this is not a perfect square if the root is 4. There is no number that can be multiplied by itself 4 times is going to give you 9 or even x to the 3.
What if you have x to the 4?
Then that can come out. We'll get to that. We will get to that.
Oh, I lost it.
Oh, I know. I know. Exactly. All right, do y'all have any questions about this? All right, let's do another example. And these are kind of important because it's new stuff. What if I have, oh, this is good, a big old radical sign with a 4 in the check mark, if y'all want to call it that. 7 times x to the 3rd y squared. And I said put it in exponential form. Franz, you want to try?
Mhm.
All right.
So 7,
Uh-huh.
and then the exponent will be 3 over 4.
Where did you get the 3?
No, 7x.
Do I have an exponent for 7?
Oh no.
What do we pretend is there?
1.
That's right. We're going to pretend there's a 1 there. So then what would this be? 7, 1 over 4.
And x 3 over 4.
X is
And
3
y
over
is
4.
Well, 1
And y is, okay, well, hold on. 2 over 4, because that exponent is 2, it goes on top. That's your denominator. And as Franz said, he simplified this little bitty fraction. So what did you get, Franz?
1/2.
All right. All of these can't be simplified, and this becomes 1/2.
So
And-
you have to reduce your fraction.
Yep, you have to reduce your fractions. Reduce. Make sure you simplify. And that's good. And it's okay. Here they have different denominators, but to be able to put it in the radical form, you have to get common denominators. But it can be simplified out. Any questions? None? All right, we're going to stop there today. Let me pause this.